Welcome to The Explainer. Today, we're pulling back the curtain on one of the most transformative technologies of our time, artificial intelligence.
You know that Hollywood image, right? The lone genius coder in a dark room, furiously typing away? Yeah, forget all that. The reality is, building a modern AI is this massive, super complex, and honestly often grueling engineering journey. It's not just code. It's about understanding hardware, data, and the messy real world where this thing has to live. So in this explainer, we're going to walk you through the 5 key stages of that builder's journey. We'll see how an engineer takes an AI from just an idea all the way to a system that actually works out in the wild. Ready? Let's dive in. All right, first up, to really get how we build AI today, you have to understand this massive shift, a total change in how we even think about creating intelligence. Okay, so early AI, it was all rule-based. Just think of like a simple chatbot from the 90s. A human programmer had to sit there and literally write out every single rule. If the user says this, you say that. But what happens if you say something they didn't think of? The whole thing just breaks. It was super brittle. But modern machine learning, it just flips that whole idea on its head. Instead of giving the machine rules, we give it data. I'm talking tons of data. And the system, it just learns the patterns on its own, finding connections that are way too complex for any human to ever program by hand. And you know, this didn't happen overnight. Not even close. The journey from when the term AI was first coined back in 1956, well, it was a real roller coaster. You had these amazing breakthroughs, right? Like IBM's Deep Blue beating the world chess champion. But then you had these long periods called AI winters, where all the funding and interest just dried up. It literally took decades of research, a lot of setbacks, and then slow, steady progress to get us to the kind of powerful learning systems we see today. Okay, let's move on to stage 2, because this is where it gets really interesting. The fuel for any modern AI, it's data. And getting that fuel, refining it, and actually getting it into the engine, that is one of the biggest, most critical jobs in all of AI engineering. See, a great AI isn't just about having a super smart algorithm. Success really comes down to what engineers call the AI triangle. You've got to have this perfect balance between 3 things: huge amounts of high-quality data, the smart algorithms or models, and then just the raw computing power to crunch it all. If any one of those 3 legs of the stool is wobbly, the whole thing falls over. And this is the absolute crucial point. You've heard the phrase garbage in, garbage out, right? Well, in AI, that is the golden rule. An unbelievable amount of an AI engineer's time, we're talking sometimes up to 80%, is spent just on making sure the data is good, cleaning it, checking it, trying to root out all the hidden biases. Because if your data is junk, your AI will be junk. It really is that simple. Okay, check this out. This is a perfect example of how easily bad data can sneak into your system. So imagine you're building the AI for a self-driving car. You're scraping the internet for millions of pictures of traffic lights. But oops, you accidentally grab a bunch of old historical photos where the lights are in a different order. Now all of a sudden, your car's AI is learning from information that's outdated, totally irrelevant, and honestly super dangerous. Engineers call this data noise, and it's the kind of thing that can cause, well, catastrophic failures. All right, so we've got our clean fuel in the tank. Now it's time for stage 3, building the digital brain of the AI. This is the training process, and this is where all the magic really happens. So it all works in this constant loop. First, you have the forward pass. The model looks at some data and makes a guess. Let's say it guesses dog for a picture of a cat. Then it calculates its error. It sees how wrong it was. Nope, that was a cat. And finally, and this is the brilliant part, it does a backward pass. The best way to think about it is like an assembly line. A car gets to the end and the inspector sees a crooked door. He doesn't just fix that car, he sends a message all the way back down the line telling every single robot exactly how to adjust so the next car is perfect. That's what the AI is doing. It's adjusting millions of tiny internal knobs and dials to be just a little bit less wrong next time. And it does this over and over and over again, millions, sometimes billions of times. And to give you an idea of the sheer scale of this, get this. The amount of computing power needed for the biggest AI training jobs went up 300,000 times in just 7 years, from 2012 to 2019. 300,000 times. That number is just insane. It completely blows past Moore's law, and it's exactly why we had to invent all this new, specialized hardware to even keep up. Okay, so now we have a trained model. It's smart. But an AI that just sits on a lab server is pretty much useless, right? So stage 4 is all about getting it out into the real world. This is what we call deployment. And this is one of the biggest decisions an engineer has to make. Where is this AI actually going to live? Is it going to run its calculations in some massive, powerful data center in the cloud? Or maybe on a local edge device, like your smart camera? Or maybe even on a teeny tiny low-power chip inside a sensor? The answer to that question completely changes how you design the entire system. Basically, engineers have to weigh a bunch of really critical trade-offs. For example, if you care about user privacy, well, you probably can't be sending personal data up to the cloud. Or what if you need a response in milliseconds? Think about a self-driving car needing to slam on the brakes. You just can't afford the delay, or what we call latency, of sending a signal to a server hundreds of miles away and waiting for a reply. So you're forced to make this choice. Do you want the raw power of the cloud, or do you need the speed and privacy of running right here on the device? And the difference in cost? It's just staggering. Look at this. If you want to deploy a system with 1,000 smart sensors using the old school approach, connecting them all to the cloud with cellular networks, you could be looking at $750,000. But if you use something called TinyML, where you run a super efficient AI model on a tiny little chip right in the sensor itself, that cost drops to just $10,000. That is a total game changer. It makes deploying AI on a massive scale actually possible. And that brings us to our final stage. And honestly, this is the one most people completely forget about. You've launched the AI, it's out in the world, doing its thing, so the job's done, right? Nope, the work is far from over. In fact, a lot of the time, the hardest part is just beginning. Here's the thing. Normal software, it's simple. It either works or it crashes. But an AI system, it can just sort of silently get worse over time. There's this phenomenon called data drift. Think about it. The world is always changing, right? But the AI was trained on a picture of the world from the past. So as new, different data starts to come in, the AI's performance can just slowly and quietly degrade, and you might not even notice until it's too late. And this is where that critical, hidden work of AI comes in. It's not just about watching the numbers. It's about wrestling with some really deep, really tough responsibilities. You have to ask, is this system fair? Or did it learn biases from its data that make it discriminate against certain people? Can we even explain why it made a decision? Is it transparent? And what about protecting user privacy? And maybe the biggest question of all, when it messes up, and it will mess up, who's responsible? These aren't just technical problems. They're huge ethical challenges. So if you take one thing away from this whole journey, let it be this. Building AI isn't some single flash of genius. It's a continuous cycle. It's systems engineering, it's constant monitoring, it's nonstop maintenance, and it's a deep, deep sense of responsibility. The real story of building AI isn't just about making something smart, it's about making something the world can actually trust.